7172 supplement compound interest. All right, the first problem we have is a review problem. It's an equation we've used before. However, we are buying a car and the value after we buy the car is going to go down. So what we're going to need to do is let our rate be negative 12%. So how we're going to fill that in? Negative 0.12. Remember, for that decimal, we need to move it 2 spots to the left. Okay, so how we're going to set that up? We're going to say the amount after 5 years is equal to the original amount, 16,000, times 1, and then instead of plus our rate, we're going to say minus our rate. And then to the time, 5 years. Okay, so the left side, you don't have to do anything with that. That's just saying the amount after 5 years. Just go ahead and calculate what the right side is to see what that car will be worth after 5 years of driving. All right, go ahead and pause the video and see if you can get that to work out. All right, the value of the car after 5 years should be $8,443.71. So we are going to learn one new equation instead of compounding it like we did in 7-1 yearly, like this, annually, or what we did in 7-2, we were compounding it continuously. Now we're going to kind of find the middle here. So we're going to review how to find that interest just annually. So this one's just like the warm-up. So the amount after 8 years, if we put $1,000 into an account and make 5% interest, is what? So go ahead and calculate that. All right, so you can see after 8 years, that amount that was $1,000 has now grown to $1,477. So we made $400 interest there, almost $500 interest. Now, what if we would compound that money a little bit differently? So this, what's happening up here is we have that $1,000 at the end of the year. It gives us some more money on it, it gives us interest. And then now we have a little bit more than 1,000. And then the next year it compounds interest on the 1,000 and that little bit more. So what's happening down here is it's going to compound it more often, semi-annually. Okay, so you should make a little bit more money doing it this way. All right, so the formula for this one is very similar. The only thing we need to divide the rate by the number of times per year we're going to compound that interest, and then multiply the time times the number of years, number of times per year we're going to compound that interest to get like the payment periods, if you can think of it. So we're going to go the amount after 8 years. We're going to do that same amount, $1,000 times 1 plus same rate, 0.05. Now, semi-annually, what that's going to be is your end value is going to be 2. And then to the time times number of times per year. So remember, A was the amount that you start with. Let's say beginning amount, initial amount, however you want to say that. And then R was that rate, make it a decimal. T is time, usually in years. And then N is the number of times per year that your interest is compounded. All right, so that's why we put in 2, since it was semi-annually. If it's monthly or quarterly, we'll do it a little bit different. Okay, when you calculate this, you can really just type it all in your calculator with one exception. It's that exponent. If I type it in my calculator just like this looks, you're gonna not get the right answer. So you either have to put the exponent in a parentheses, like to the 8 times 2 power in parentheses, or just do it in your head. A lot of times it's an easy number. You can just calculate it real quick. All right, so go ahead and calculate that. Again, typing for that fraction bar, just put a divide sign. So it's going to be like 1,000 parenthesis 1 plus 0.05 divided by 2 parenthesis to the 16th. So look like that in your calculator. All right, so if we compound that interest semi-annually, we should make a little bit more money, $1,484.51. So made a little bit more money, not too much more, but a little bit more. Okay. Let's try the next one. What if we do it even more often? We compound it quarterly. See if you can think what n would be if we're compounding it quarterly. Think how many quarters are in a year. We're on semesters, but some schools are on quarters. So that would be letting n be 4. So we're going to use the exact same numbers and see that the more often you compound that interest, the more interest you're going to gain. So this time I'm going to do 0.05, but divided by 4. And then to the 4 times 8, 8 times 4, we'll do it that order. So again, that's the part that can mess you up on your calculator. You've got to make sure you multiply it in your head, or make sure you use parentheses when you type it in your calculator. So 8 times 4, 32. Okay, so then we can calculate that, and it should be $1,488.13. So not too much more than some semi-annually, but you can imagine if this was like $10,000 or something, like the bigger the amount is, the more it's going to impact it. All right, let's jump to the next page. Okay, what would be the best case scenario where you're accumulating the most money? If interest is compounded monthly, go ahead and think of what your n would be. How about weekly? Do you guys know how many weeks there are in a year? Or daily? So you can think of what those n's would be. And then go ahead and find the daily. All right, so how many months in a year? 12 months in a year, so n would be 12 in that case. Weekly, 52 weeks in a year. Daily, 365 days in a year. So if I wanted to try that daily, we're going to still find the amount in the account after 8 years of that $1,000. Our rate is still 5%, but this time I'm dividing that by 365. And then to the 365 times 8. So again, it might be good to calculate what that 365 times 8 is before you type it in your calculator. Or before you just calculate the rest of it. So 365 times 8, 2,920. Now you should be good to go to type it in your calculator. All right, so we creeped up there a little bit more. Quarterly was $1,488. Now we're up to $91, $1,491. And there is one more method that can get you even more interest. We did this yesterday. This is when that interest is compounded continuously. Okay, so this was that PE to the RT equation. So we're going to do this one more time. The amount after 8 years of $1,000 E to the rate times time. Rate was 0.05 times time 8 years. So you don't have to have an in at all on this problem because we're not doing it blank like set 12 times a year or 52 times a year. We are doing it continuously every moment. So if we calculate that, we get $1,491.82. So just slightly more, 4 cents more than if it was compounded daily. So daily's almost as good as continuous. All right, we'll come back to that last problem tomorrow, but go ahead and work on that next page in your packet, 7172 compound interest worksheet. Work on that today and tomorrow. So if you get stuck on some, we can work on some of those in class tomorrow. Okay? All right. Good luck with your assignment. Let me know if you have any questions. Thanks. Bye.